All right, guys, so what we're doing today is we're continuing on with Chapter 6, 6.4. What we're talking about today is mid-segments. The mid-segments of a triangle is a segment that connects the midpoints of two sides of the triangle. Every triangle has three mid-segments, so they're just a line that connects midpoints on the triangle. So MP, PN, and NP are the three mid-segments of the triangle. Now it works out that the mid-segment, so this side here, is congruent to these two here. This mid-segment here, MP, is going to be congruent to these two here. And PN is congruent to these two here. So whenever we draw the three mid-segments, we will have three sets of congruent sides every single time. And not just that. A mid-segment and the side opposite it are parallel. So DE is a mid-segment of ABC, and DE and AC are parallel, and it's equal to half of its length. And that's it. So let's look at kind of some of the mid-segments. So we want to complete some of these statements. Well, JK, this line here, so make it red so it's a little bit easier to see. JK, this segment here, is going to be parallel to what? It's going to be parallel to the side over here. So it's going to be parallel to line YZ. So it'll be parallel to line YZ. These two lines are going to be parallel. Now you could have called it YL or LZ or LY, any way to name this line, but these two lines here are going to be parallel because JK is the mid-segment of the line. It's one of the mid-segments. So these two are going to be parallel. Now, it also asks us about JL. So I'm going to make it a different color. Let's go with, well, not blue. Let's go with teal. This line here, JL, well, it's going to be parallel to the line opposite it, which is going to be this one down here. And that line down there is going to be XZ. And these two here are going to be parallel. They're going to be parallel lines because those two are parallel to each other. Now we do have another set of parallel lines because they're going to talk about this one here, XY. XY, this line here. Well, it's parallel to the mid-segment opposite, which would be KL. KL is going to be its mid-segment. So these two lines are parallel because the mid-segment and that opposite side are parallel to each other. Now, as I said before, so those are the parallel. Now, each one of these triangles is going to have three sets of congruent sides. There's three sets of sides that are going to be congruent to each other. Now, these two, if we say that these two, because this is the midpoint, so these two would be congruent, and its mid-segment. This mid-segment and its two sides are all going to be congruent. And this mid-segment and its two sides are going to be congruent. Now let's look at what line they're talking about. Go back to that teal. JY is this segment here. Well, we know one of the segments that is going to be congruent to it is going to be the other half of that line, which is JX. Because JY and JX are going to be congruent because J is a mid-segment or midpoint. Now its mid-segment would be KL. So JY, JX, and KL are all congruent because they're all the same. They're all going to be the same because of our properties of mid-segments. So they all work out to be the same length. So continuing on with this here, so we have JL. That's going to be congruent to our other two parts of the line, these two here, because K is a midpoint. So xk and kz are going to be congruent to each other because k is a midpoint, and because of our mid-segment property, all three of these segments are going to be the exact same. With this purple. Now jk, yl, and lz are all going to be congruent because of our properties of mid-segments. So jk, yl, and lz are all congruent because of the properties of mid-segments. And I'll go on and fill the ones we did first back in here. So we said that these here were congruent as well. And that's it. Now when we look at this here, because when we have all these mid-segments, we actually have 1, 2, 3, 4 congruent triangles when we draw the mid-segments. So when we draw the mid-segments in, it actually creates 4 congruent triangles that we have. And that's it for this part. Now we want to use the mid-segment property to find the value of x. DE is a mid-segment of ABC. Find the value of x. Well, the mid-segment is equal to half the bigger length. So for this here, x is equal to half of DE. It's equal to half of DE. Well, DE is told to us to be 26. So half of 26 is going to be 13. And that's it. That's all we have to do for this here. So to find x, well, it's half of the bigger length. So it'd be 13. Now this here, so we know that 5 is equal to half of the bigger length. So if I'm going from bigger to smaller, I divide it by 2. To go from smaller to bigger, I wouldn't divide it by 2, I would multiply it by 2. Or another way we can see it is that what we're saying is 5, the mid-segment, is equal to 1/2 of x. Well, if I want to find the value of x, all I need to do is divide both sides by 1/2, or multiplying by 2, either way works. 1/2 divided by 1/2 will simplify. Anything divided by itself is 1. And 5 divided by 1/2, if you plug that into a calculator, you would get 10. So we'd either divide it by 1/2 or multiply it by 2. And that's it. Now, looking at this here, well, we've mainly been dealing with these two here because DE is equal to half of AB, and AB is twice DE. But again, point ED is a mid-segment. A mid-segment connects the two midpoints. So if they're midpoints, it means that EC is equal to AE. So x is equal to 6. Because these two lengths are going to be the same because it's a midpoint. It cut the line in half. It's where its middle is at. It's where the middle of the line is located. So x would be 6 here. And this here would be almost the same thing. So it's DE is a mid-segment. So it means it's connecting the midpoints, which tells us that AD and DB are congruent. BE and EC are congruent. So if I want to know the value of x, well, for this here, x is going to equal 8. And that's it. That's all we have to do for this here. D is the midsegment of ABC. Find AC. Okay, well now it's not asking for EC. It's asking for AC the whole line. But I can find EC pretty easily because EC is going to be 4.8. Point E is the midpoint. It's the middle of the line. So EC and AE are congruent. They're the same. They're the same segment. These two here are the same. And so if I want to find AC, I just need to add its two lengths, so 4.8 plus 4.8 together to find the length of the entire line. And it would tell me that AC is equal to 9.6. I just had to add the two parts together to equal the whole. And that's it. That's all we have to do for this here. Okay, mathematical connection. In exercises 17 through 19, use triangle GHJ, where A, B, and C are midpoints of the sides. So they're midpoints. So they are midpoints. And since they're midpoints, it means, well, that these three here are congruent. These three here are congruent. And these three sides here are congruent. Okay. And that's going to be kind of handy to know. Now, for this here, it says when AB is equal to 3x plus 8 and GJ, the other side, is equal to 2x plus 24, what is AB? Well, I know AB is equal to 1/2 of GJ. That's just our mid-segment property. AB, the mid-segment, is equal to half of the big side. And we can use that. Because I know what AB, well, I don't know what AB is, but I know AB is equal to 3x plus 8. So we'll replace that. 3x plus 8 is equal to 1/2. I'll draw that in. 1/2 of GH is 2x plus 24. So looking at this here, well, we need to solve. We need to solve for the value of x. Now we can multiply through by 1/2, and that's fine, or I can multiply both sides by 2, either way. Now what I'm going to do is I'll go on and multiply through the parentheses by 1/2, because again, we want to find the value of x. Because once I find the value of x, we can plug it back in. So if I multiply through 1/2, well, 3x plus 8 is not going to change. Equals, well, 1/2 times 2x, 1/2 times 2 is 1, so we'll just have x, plus 1/2 times 24, or 24 divided by 2, would give me 12. So here it worked out nicely that I can multiply through by the 1/2. Now the next thing we're going to do is to get x by itself. So I'm going to subtract x from both sides of the equation. And when we subtract x from both sides of the equation, we'll get 2x plus 8 is equal to 12. And then again, we're still solving for x, so we would subtract 8 from both sides of the equation. And when I subtract 8 from both sides, well, 8 minus 8 will cancel, leaving me with 2x is equal to 4. And last but not least, we're going to divide both sides by 2, leaving me with x is equal to 2. And that's our answer there. We found the value of x. Now all we need to do next, the last thing we need to do is we just need to plug it back in to find AB, the length of AB. Now it told us that AB is equal to 3x plus 8. So AB is equal to 3x plus 8. So if I want to find this, I just need to plug in 2 into x, 2 into x. So we'd have 3 times 2 plus 8. Well, 3 times 2 is 6. And 6 plus 8 will tell me that AB is equal to 14. So the length of AB for this problem here is 14. So the first thing we had to do is, well, okay, because it's midpoints, as A, B, and C are all midpoints of the sides, it means that we have these congruent parts, which told me AB is here. Now I know that AB is equal to half of GJ, so I set it up and solved for the value of X, which I found to be 2. I plugged it back in to the equation for AB and found the length of AB to be 14. And we're done with this here. So we have 2 problems left, this one here and one more, so 2 problems left, and then we are done with this lesson here. Now again, we have the same triangle with A, B, and C being midpoints. We're told that AC is equal to 3y minus 5, and HJ is equal to 4y plus 2. We want to find the value of HB. Well, HB, AC, and BJ are all congruent. These 3 lengths here are all congruent. So if I can find the value of y and plug it back in for AC, I will know the value of HB. And what we know so far is that AC is equal to 1/2 of HJ. So that tells me that 3y minus 5 is equal to 1/2 of 4y plus 2. Excuse me. I'm going to go on and write that in, that 1/2. And what we'll do next is we're going to distribute the 1/2. We're going to multiply it through. So if I multiply this through, well, 3y minus 5 is not going to change. Is equal to, well, 1/2 times 4y, or 1/2 times 4, will give me 2y. And 1/2 times 2 will give me 1. So this one here, again, it worked out nicely, multiplying through the 1/2. Now the next thing I need to do is I just need to solve for the value of y. So I'm going to get y by itself, or get y's on the same side. So I'm going to subtract 2y from both sides, because 2y minus 2y will cancel. And 3y minus 2y will leave us with just 1y. So we have y minus 5 on one side is equal to 1. Now the next thing we need to do is, again, we're trying to get y by itself. So this time I'm going to add 5 to both sides. And when I add 5 to both sides, I'm left with y is equal to 6. So I found the value of y. Now I just need to find the length of HB. Well, I know that HB is equal to AC. HB and AC are going to be equal. And I know AC is 3y minus 5. So I just need to plug in the value of y and solve to find the value of HB, or the length of HB. So this would be 3 times 6 minus 5. Well, 3 times 6 would be 18. And 18 minus 5 will tell me that HB is equal to 13. So the length of HB is 13. And we are done with this here. So we set it up using our properties of mid-segment, and we set it up. We solved for the value of y and found that it's 6. Plugged it back into AC because we know the equation for AC is the same as HB, and found that the length of HB is 13. And so we're done with this problem here. So that brings us to the last one here, this one here. Now GH, the entire length, these two here are all congruent, but we also know that CB is equal to 1/2 of GH. So we know that CB is equal to 1/2 of GH. Or that GH is equal to twice GB, or CB. So we do have that this is true. This is true. But we also have that GH is equal to 2 times CB. It's twice the length of CB. Now, I bring this up because this one here is actually going to be easier to use, not this one here. It's not going to be as easy to use this here because, let's look at it. Let's go one step and let's actually see this. 4z minus 3 would equal 1/2 of 7z minus 1. Now up to this point, the two numbers that we've been multiplying by 1/2 have both been even, so they would divide evenly. But here, 7 and 1 will not divide evenly, so they'll give us decimals. So this one here, it might be easier to use this one over here. Because if we look at this one here, well, GH, so if I plug it in for this here, GH is our 7z minus 1 is equal to 2 times 4z minus 3. Now this one here is easier because we're multiplying by a whole number, not a fraction, so we don't have to worry about reducing or having things divide evenly. So if we do this here, I'll come back to this first one. Let's do it this way here. So what I would do first is I would distribute the 2. And if we distribute the 2, well, the 7z minus 1 is not going to change. But 2 times 4z will give us 8z. 2 times negative 3 would be negative 6. Now we just need to solve for the value of z. So I'm going to get z's on the same side. And to do that, I'm going to subtract 7z from both sides. The 7z minus 7z will be 0. And what that leaves us with is negative 1 is equal to z minus 6. And again, we still need to get z by itself. So what I'm going to do is I'm going to add 6 to both sides. And when I add 6 to both sides, what I'm left with is that z is equal to 5. And that's the answer. That's the value of z. Now I want to find the value of GA. Well, GA will be the same as CB. So I just need to plug z into our 4z minus 3. So I'm going to take 4z minus 3 and plug in the value of z. So it'd be 4 times 5 minus 3. Well, 4 times 5 is 20. And 20 minus 3 will tell me that the length I'm looking for, GA is equal to 17. And that's our answer. That's all we have to do for this here. That's all we have to do to find the value of GA, the length of GA. We found the value of Z, plugged it back into the smaller length, and found it. Now the reason I choose the smaller length and not the bigger is because if I plug it into the bigger one, I would have to divide it by 2 to get the smaller length. Now this one here, again, I kind of left this here, 4z minus 3 equals 1/2 of 7z minus 1. Now I'm going to go on and finish this one out here. I'll show you why I didn't do this here. It's not that it won't give us the correct answer, because 4z minus 3 will still be the same. But when I distribute 1/2 times 7z and 1/2 times negative 1, we are not going to get whole numbers. Because 1/2 times 7z, or 7 times 1/2, will give us 3.5z minus 0.5. Because negative 1 times 1/2 is going to be 0.5. And this is why I normally don't do this one here, because we get decimals. And it's not that it's going to change the answer. We'll get the exact same answer. Now the next thing I'm going to do is I'm going to get z on the same side. So I'm going to subtract 3.5z from both sides. So we subtract 3.5z from both sides. So these here will cancel. And what that will leave me with over here is I will have 0.5z minus 3 is equal to negative 0.5. Now again, we're still trying to get x by itself, so this time here, I'm going to add 3 to both sides. And if we add 3 to both sides, what I'm left with is 0.5 should be z. 0.5 z is equal to 2.5. 0.5 z is equal to 2.5. Now z is not by itself, so to get z by itself, I'm going to divide both sides by 0.5. And if I divide both sides by 0.5, I get that z is equal to, not n, but 5. I get z is equal to 5. Well, that's the exact same thing we got doing it the other way. So I do it the other way because since it won't divide evenly, since multiplying by 1/2 here, let's get the highlighter. Since multiplying by 1/2 here does not give me whole numbers here, I went this way. I did it this direction here because it's a little bit easier. Now, all the ones we did previously, it worked out that when I multiplied through by 1/2, I got whole numbers. So it works because those two numbers were even. Now, this one here, it didn't because 7z minus 1 was not whole number, or not even numbers, not even numbers. When we multiply by 1/2, it will not give us whole numbers. So it doesn't work out as well. But we can still do it and get the same answer. But we have to deal with some decimals. And that's the only real difference. And that's all we're going to cover today. And I will see y'all tomorrow.